how would we solve an equation like this? Now, it says sine beta equals 3/4. Now, of course, typically when we've had a trig equation, we get down to this step where we just have the trig function equal some number. We immediately think, well, we'll look on the unit circle and find the y-coordinate that, for example, we'd look for the y-coordinate of 3/4, and we would have our solution. Just see what angle was associated with that. But the problem here is we won't be able to find 3/4 on the unit circle. It's not one of those special numbers that we have on the unit circle. So we need a different approach to find out what the solution is. In other words, we're trying to find out where sine beta equals 3/4. Now here's the technique that I would recommend to you. I'm going to recommend that you use your calculator and solve this by graphing. So here's what you want to do. Once we have it in this form, open my calculator. We simply, now I want to make sure I'm in, I'll tell you what, I'm going to go into degree mode. I'm going to solve this in degree mode because we're a little bit more comfortable with working with degrees in knowing where things are on the unit circle if we're in degree mode. Because if we're in radian mode and we solve this equation with the method that I'm about to give you, we're going to get some decimal results that are not in terms of pi. So it takes us a little bit out of our comfort zone because we know what pi over 3 is, but we're not so comfortable with seeing a radian measure that's strictly in decimal form without a pi in it. So I'm going to go into degree mode, and as you can see, I'm in radian now, so I'll just go into degree. And now, once we're in degree mode, once I change my mode, I'm going to go ahead and solve this graphically this way. First thing we need to do is we need to get everything on one side of the equation and have a 0 on the other. So what I need to do is bring the 3/4 over. I just subtract 3/4 from both sides. Now after I subtract 3/4 from both sides, I go into y equals and clear out anything that's in there, and now I'll just put sine x minus 3/4. So here I go. Sine x, and we use x just because that's the variable that the calculator provides us to use. We don't have a beta, so I'll just use x. Minus 3/4. Okay. So we have sine x minus 3/4. Now, the way we use our calculator to graphically solve an equation is we'll just graph this equation, this function, and look for where it crosses the x-axis, because we're saying that sine beta minus 3/4 equals 0. Well, we'll graph that. This is just now notice this is just going to be the graph of sine that's been shifted down 3/4 of a unit, right? That's all that is. It's just the sine function that shifted, has a vertical shift down of 3/4. And what we're doing is we're saying, well, where does the function equal 0? In other words, where does it cross the x-axis? Where is the y value, the height, 0? Well, wherever it crosses the x-axis. So that's what we're looking at. Now, before I do this, I want to set my window so that I can kind of simulate one revolution around the circle. In other words, 3/4 is not on the circle, but if we were looking at the unit circle, we'd be looking at 360 degrees. So what I'm going to do, I'm going to go into my window and set this from 0 to 360. Because I want it to be like I'm looking at one revolution around the unit circle. Okay. So I set it from 0 to 360, and I'll set my y min to be, let's say -2. This is not as important, but we want to be sure we get the x-axis in there. So I'll set it from -2 to 2. Now, by doing this, what we're going to do is we're going to see every place between 0 and 360, or between 0 and 2 pi, where it crosses the x-axis. So now I just graph it. Okay. and you see two places right here. Okay, you see a place here and here. Now those are the only two places, right? Okay. Now, we're ready at this point to go ahead and find those intersections, where it intersects the x-axis. So I'm going to do this procedure. I'm going to second, calc, and I'll go to this part, number 2 here, 0. Okay. And the first thing it asked me for, the calculator is wondering, well, which place do you want? It's got a couple places here where it crosses the x-axis, and it's asking us, well, which one do we want? So I'll just arrow over here, and you arrow until you go to the left of one of your zeros. And I'm going to start with the one on the far left. So I arrow over, and you just keep arrowing over until you get to the left. Notice I'm still to the right of where it crosses. So I come over here to the left. Now I'm to the left. Now as soon as you get to the left, just enter. And now notice it immediately says, well, what is the right bound? So I arrow until I go to the right, and I hit enter. And now it wants you to put the cursor about where you think the x-intercept is. Well, typically you don't have to do that. I'm just going to hit enter again and see if it gives me, see, it put the cursor on the intercept here. Okay. So notice it's left bound, right bound, enter, enter. Okay. And notice it gave us about 48.59 degrees. So we would say this, beta, what was it, 48.59 degrees? Everybody see that? Okay, now y'all take a minute and try to find that second one. Using the same procedure, try to find the 0 to the right. Okay, so what did you get for the answer? 131. 131 point what? 441? Okay, now, look. These are the two solutions we got. Now, let's just look and see another way that we could have found this solution once we had this one. Now, remember, we're not completely finished because we still got to take care of the coterminal angles. But let's, just for a minute, let's look at a circle. Okay. Now, look. We decided, we found our two solutions. Let me make a circle. And we found that one solution was about 48.59, over here somewhere. Now, what quadrant is this solution in, 131.41? The second one, right? Now, in other words, here's 180, here's 90, so it would be about right here. Now, look, notice there's some symmetry here, right? Just because 3/4 is not on the unit circle doesn't mean that there's still symmetry. In other words, we found the degree that's associated with this y-coordinate of 3/4. Well, remember the symmetry. If it's in quadrant 1, then it's also going to be in quadrant 2, right? Do y'all see that? The y is positive in both of those quadrants. So if we knew that this angle over here was 48.59, 48.59, is there any way we could have just real quickly figured out what this angle is here? I gave you a hint there. Any way we could have done that? Let me ask you this. What is this angle right here where this arrow is pointing? What is that angle? Just looking at that angle. Not this whole rotated angle here, but what is this little angle? What do you think it is? Well, look, this is 48.59. It's 48.59. That's right, because of the symmetry. So if I wanted to get the 131.41, I could have said this. I could have said, well, I've got this angle. The next one is just going to be 180 minus 48.59. Now, because we rounded, it's not going to... In other words, if we just do one... see what that gives you. Take 180 minus 48.59. So when you subtract that, you see you get approximately 131.41. Now, if we had gone a different approach, if we had taken a different approach to solving this equation, that would be something we would need to keep in mind. For example, if we had not solved this equation graphically, if we had just simply decided to use the inverse method to solve this, in other words, if I had said the inverse sine of 3/4, I would have gotten 48.59. I wouldn't have gotten the 131.41. So if you don't use the graphing method, if you just do inverse sine of 3/4, you would get this. But you would have to still get this. You would need to say 180 minus 48.59. But we'll look at that inverse method a little bit more later. Now let's look at another example of one that's just a little bit different than what we've looked at so far. Let's suppose that we have sine squared beta plus, let's say 3 sine beta plus 2 equals 0. Okay? So we've got sine squared beta plus 3 sine beta plus 2 equals 0. Now, we've not looked at any trig equations like this before. Any ideas about how we would approach this? Well, just think about this. What if instead of sine squared, we had x squared plus 3x plus 2? Now, you are, Eli, you're correct. The first thing we do is solve for the trig function. But in solving for this trig function, it's going to be a little more complex than that method. If we were solving this for x, what would you do? Yeah, you could factor this into x plus 1, x plus 2. Right? And then we have, well, x equals -1 or x equals -2. Does everybody remember that? Well, how would we take care of the trig equation then? That's right. We treat the sine just like it was x. We say sine beta plus 1, sine beta plus 2. And now, look what we've got. Now we set the first one equal to 0, right? Sine beta plus 1 equals 0, or sine beta plus 2 equals 0. Okay? Or we could rewrite it as sine beta equals -1, or sine beta equals -2. Now, let me ask you this. Is there anything I can do right now to really cut my work down? There's an observation I can make at this point that will make things easier. Well, do you see anything wrong with either one of these equations? Is any fundamental idea violated here? Look, sine beta can equal -1, right? We know of places where sine is equal to -1. What about this? What about the sine of beta equals -2? No. Sine beta cannot equal -2 because remember the range of sine is -1 to 1, right? So immediately we can just cross that out. That part of it has no solution. That's just something extra that's there. It's not going to contribute to our solution at all because sine beta is never equal to -2. Sine beta can only equal numbers inclusive between -1 and 1. So where does sine... Okay, so all we have to worry about is sine beta equals -1. Now, where does sine beta equal negative 1? On the unit circle, just look at one time. Well, think about this. Where does sine equal 1? You're right. Chad, yeah, it equals negative 1 at 270. That's right. So what we could do is we could say beta equals 270 plus 360k. If we're in degree mode. You know, if we're dealing with degrees. Now, if I were talking about radians, what would beta equal? It's got a 3 in it. Not square root. What is the radian measure that corresponds to 270? That's right. Eli got it. 3 pi over 2 plus 2k pi. So those are the two ways that we could write this solution. Any questions about that? So look, we've learned a couple of new things. One, how do you deal with a trig equation that it's not got a nice value that we can use on the unit circle? You know, one of our special angles. It's not associated with any of our special angles. Well, the graphing method. Set your calculator between 0 and 360 or 0 and 2 pi and just note where it crosses the x-axis. And then use what you know about your trig function to get the other angles, if need be. And we've also learned, well, if we've got something that looks like a quadratic equation, maybe we can factor it. And then solve it just like we were solving a quadratic equation.